Okay, on a second time part of things, it's another part of rates of change is what we call connected rate of change. Okay, connected rate of change is very interesting. Um, we consider a variable y that is changing 3 times as fast as another variable u. Um, so you, and then we realize that u is also changing 5 times as fast as the variable x. Okay, how fast is y changing with respect to x? Right, so let's kind of just connect them in some sense. Right, if y is changing as 3 times as fast, so I can write it as y equals to 3u. Right, so sorry, wrong color. Okay, y is 3 times of u. Right, and u is changing 5 times as fast as the variable x, so u is equals to 5x. How fast are they changing with respect to x? And so these rates of change can be related to each other by chain rule. So we have dy over du. Sorry, just give me a moment. Okay, we have dy over du, which is equals to 3, and you have du over dx, which is equals to 5. And so the rate of change of y with respect to x is actually dy dx, right? It's simply dy over du times du over dx, which is simply equals to 3 times 5, which gives you 15. Pretty straightforward, nothing too difficult. Alright, so then let's consider something else, right? Consider an example where air is actually pumped into a spherical balloon, right? And a spherical balloon is something that we cannot really, it's not linear, right? The way it grows is not linear. Okay, and it's pumping into it at a constant rate of 100 cm cube per second. How fast is the radius of the balloon changing when the diameter is 20 cm? Wow. Okay, so we're trying to find the rate of change here of the radius, in fact. And finding the radius is very important. And in this case, what can we make sense of this whole thing, right? There's no x, there's no y. So what we're gonna do is, what we know here is that there is a constant rate of 100 cm cube per second. Now, cm cube gives us a clue that this is in terms of volume. So there is volume being pumped in at 100 cm cube per second, right? And this actually tells us that the the rate of change of the volume with respect to time, which is dv over dt, is equals to 100 cm cube per second. Okay, makes sense, right? Because the units here actually give us a clue, right? That the volume is being pumped at 100 cm cube per second, and that would simply mean that dv over dt is equals to 100 cm cube per second. Now, how fast is the radius of the balloon changing? What is it changing with respect to? Okay, it's definitely changing with respect to time. So in fact, the question here is actually asking you, what is the radius? I'm going to use r for the radius and v for the volume. dr over dt equals 2. Okay, when the diameter is 20. So this will actually tell us over here that since the diameter is 20, radius must be equals to 10. So when r equals to 10. So a question alone gives us a lot of clue. But the problem is, what is the volume that we're trying to find? What equation are we trying to find, right? And hence that is actually found in the question. It's a spherical balloon. So what is the volume of the sphere? So we're going to let V be the volume of the sphere. Okay, and what's the volume of the sphere? Even for me, I have to remember this quite, if I'm not wrong. Okay, the volume of the sphere is 4 over 3 pi r cube. Yeah, correct, 4 pi r cube, right? So in fact, okay, if I want to find dr over dt, there's some form of chain rule going on here. Why? I can find what's dv over dr. Okay, if I want to find dr over dt, this has to be dr over dv times dv over dt. I have dv over dt, but the problem here is I do not have dr over dv. Does that mean that I have to make r my subject and differentiate with respect to v? Not necessarily. Remember, for differentiation, if you can write dr over dv, you can also write it as dv. It's just a reciprocal of dv over dr. And hence, what we can do here is very simple. I'll figure out what is dv over dr first. I'm going to shift this to one side. So dv over dr is simply equals to 4 over 3 pi differentiate r cubed, which is 3r squared, and you'll get 4 pi r squared. Interestingly, 4 pi r squared is the surface area of the sphere, right? That's for something for next time, right? And so what is dr over dv? dr over dv is simply just the reciprocal, 1 over 4 pi r squared. Alright, so we can simply now find dr over this guy over here. Okay, this is supposed to be equal sign. I don't know why my iPad is not sensing very well. Okay, and this is when at r is equals to 10, dr over dv is 1 over 4 pi r squared. From the question, dv over dt is 100. And over here, we have r equals to 10, right? So 1 over 4 pi 10 squared. Right? And so, the rate at which it's increasing is in fact as simple as 1 over 4 pi. 1 over 4 pi is pretty small. The rate at which the radius is increasing, right, per second. So actually this would be 1 over 4 pi cm per second. And that is how you find how fast the radius is changing, with respect to the time. Alright, so I hope this kind of explains connected rate of change. It's quite similar to chain rule in some sense. Okay, so that's all.